Hello everybody. For those that don't know me, my name is Steve Hill. My day job, is as Chief Scientist at Geoscience Australia, but my today job is given the title of moderator for this event. Moderator, I hope that I do have to moderate the passion in here. I hope that moderation is part of the theme, because that means that everybody is passionate and fired up. And my role really is to help channel that passion and enthusiasm that you all have into fantastic outcomes. So you'll be seeing a bit of me today, and then we have a group of people that are doing that role tomorrow. Malcolm acknowledged country as part of his welcome to the Academy of Sciences. I think what we're looking at over the next 2 days is a very strong acknowledgement of planet. We don't often think about that when we think about our lives, where we live, and do things like acknowledge country, that we are all part of a planet. And planet Earth brings together a whole lot of different features and characteristics that are essential for our lives, our sustainability and future. And I think that's a really important foundation and starting point for what we're looking at today. We live in times where our knowledge of the Earth in general is greater, or at least as great as it's ever been before. Hopefully greater. I like to think that we are incrementally and through jumps increasing in our knowledge and understanding of the Earth. However, traditionally, we tend to do that work within what we often refer to as silos, or within our area of safety, within a subject matter expertise stable or corral. Today and tomorrow is really about breaking down those boundaries and ensuring that we are open to and celebrate and realise the ever-increasing need and potential for bringing our sciences together, and particularly across the 5 spheres of the Earth. I'm really excited about that concept. The way that we're structuring it is that for today, we are starting in a somewhat safe zone of each of the 5 silos, but it's from each of those that we're looking outwards towards integration. And I think tomorrow, once we've achieved that today, tomorrow it's going to be great that we're going to be in that space where we are truly looking at integration from a viewpoint outside of those silos. But to start things off, we're going to be looking at each of the 5 main spheres. We're going to be having an invited speaker who is, I guess, well seasoned in the science of that area, followed by an early career researcher, and then we're going to have a panel discussion. The important thing about this is that, yes, we're going to be hearing some amazing stuff and from amazing people, but the way we're structuring this is also dependent on all of you being part of the conversation. So if you don't like what you've heard or that you're hearing, you have some responsibility around that, because you're part of what we want to think about as a conversation over the next 2 days. And one of the objectives of that is not just to have a nice conversation and walk away and go back to what we've always did before this meeting, but to look to build a community of people that are well on their way to having gone through what we've done, what we're going to be doing in the next 2 days, and taking that forward. Because although the science is paramount, it's amazing how the people that are part of that community and part of that science are typically the engine room, but potentially also the source of inhibition. So how we can work through that is going to be really important. And one of the objectives is to produce a white paper. That's a lowercase w in white, that can then provide that record of what was discussed, and then also discussions about how we're going to take things forward. I did say that this is going to be a conversation, and in the spirit of that, I'm just going to look over towards Tim Rawling, who's been fantastic in doing a lot of the hard work and heavy lifting in pulling this together, and just ask Tim, is there anything either I missed or that you want to add to that opening, Tim?
Thanks very much, Steve. No, look, there isn't. We want you to be involved. We do want it to be not a talk fest. We want it to be a conversation, as Steve said, and we want to develop ideas amongst this whole group. And we do want to influence policy. We want to influence the way we do science as a community. We want to create collaborations over the next couple of days. And we do want to pull together what we think can be a really powerful piece that can not only influence the way the funding bodies think about funding integrative science, but can also influence the way we engage with each other, the values that we bring to the table when we do that, and the way we approach thinking about these bigger picture problems which we're going to face over the next decade as a science community. So it's a really important opportunity. We'll invite everybody that's in the room to be involved in putting together that paper. We haven't worked out how we're going to do that yet, but we make this guarantee that you will be involved in that in whatever way you want to be. And we want it to be a representation of what this community needs and wants to break down barriers, break down silos, and to build a better research environment for doing integrative science in this country. So get involved. That's all I can ask. Thank you.
Terrific. Thanks for being part of that conversation to start us off. It's a great way of capturing the spirit of what we're after in the next 2 days and why we're here. Okay, I'll get back to being moderator, which I think, as I said, hopefully I do have to moderate the passion because that's a great part of a community event like this. I think the other task that I've got is to be able to stand up here and then sit down in those comfy chairs and then get up again without making old people noises as I come back up to the stage. So wish me all the best there. So I think I'm going to break rule number 1 and gloat about us being on schedule. I think we are on schedule though, and we're ready to cross over to our first speaker. So Jayden, I might ask you to come up and do your magic with your computer and push buttons. Otherwise, I impersonate a chimpanzee that may happen upon typing Shakespeare.
Please check that share screen's enabled.
How do you check that? Okay, so while Jayden's doing that, I just want to introduce our next speaker. We're very fortunate to have live online, which is always somewhat ambitious, but I'm sure we can do it. Dalia Kirschbaum from the NASA Goddard Space Flight Center. I can see Dalia's name on screen. That suggests to me that we have connection. Is that right, Dalia?
Hello,
Hi,
greetings.
Dalia. Over to you. Thank you very much.
Perfect. Well, I'm going to share my screen and we'll get this going. Let's do a quick check. All right. Can you all see this?
We can, Dalia.
Perfect. Okay. All right. Well, it is a privilege to be with you. I want to thank the organizers for the invitation. We were originally connected via Crystal Johnson, who is one of the leaders of our center at Goddard Space Flight Center, and she has been collaborating with Australia for quite a long time with the Australian Space Agency and many of its partners. And so we have a long history in collaboration across our countries and in kind of the spirit of understanding how our planet is working. I just want to highlight right off the bat that it couldn't be a more apt title for this meeting, integrating Earth and examining the linkages and processes, because that's what we do. That's what we do at NASA, that's what we do as scientists from around the world, and that's where we are striving to go. So what I'd like to present a bit on today is what NASA's doing in connection with its international partners to really advance that awareness of our own blue marble, right? We are unique in the universe, and we are striving to understand as NASA where there is life, but the best analog for understanding life is right here on Earth. And so I lead the Earth Sciences Division at NASA Goddard Space Flight Center. We have the largest collection of Earth scientists in the world, really examining all of the spheres that you've introduced. And I'm really pleased to be sharing with you some of the work that we've been doing, as well as hopefully hear from you if you have any questions about how we're moving this work forward. So first, I want to give you the purview of what we're talking about when we're talking about this blue marble. Well, NASA, along with its partners, is developed over 24 satellites that have their eyes pointed down at Earth, helping us to understand how water in the atmosphere, on land, under the surface is moving and changing. And we do that from many different vantage points. You can see those orbiting along the equator, in the poles, in other orbits called non-synchronous or inclined orbits. And this is really giving us these vital signs of how our Earth is behaving, understanding and observing the past and present, and then developing models to understand the future. But we don't just do this as individual instruments. It's critical to understand these as linked, right? These linked spheres. So what you're seeing here are some of the examples of how we are connecting different types of observations, both clouds, for example, from our partners at NOAA, the National Oceanographic and Atmospheric Administration, precipitation from satellites that allow us to, with high detail, look at precipitation. And then, of course, how that impacts our land in soil moisture, how that impacts our oceans and the winds associated with them. And then, of course, how it impacts our atmosphere and how the whole system behaves. And so the theme of this talk, which seems to be highly relevant with the session and the meeting today and tomorrow, is what we're focused on is innovate, integrate, and inform. And so what I'd like to do is talk to you through some of the different ways in which we are doing all three. And I hope that it really resonates with many of the scientific advancements that we've all shared together as a community. And just to put a quote up there, you know, I'm sitting actually at NASA Ames Research Center, which is outside of San Francisco, because tomorrow the Earth science leads from all of the NASA centers are meeting together to talk about what is the future of Earth science, of the Earth Science Division at NASA. How can we transform science to action in the form of solutions? And so we do that through innovation, as only science and technology can. Now, of course, we innovate by making progress in different types of journals, different scientific discoveries. And these are just some of the examples of contributions from my center, really highlighting the breadth of both fundamental research as well as applied information that goes into popular science type outlets. And so I want to take you through a bit of what we're learning. You know, what are the new advancements? First, we can look up to the Arctic. Now, we know that the Arctic is the Earth's air conditioner, right? And so knowing the extent of the sea ice, knowing the depth of the sea ice is critical to understanding the ability to reflect radiation into space or to absorb it in the dark seawater. And so over time, what you observe is a decrease in the Arctic sea ice minimum. And we have observations from optical platforms like MODIS, as well as key observations of ice thickness, such as from the ISAT and ISAT-2 satellites, help us to look at that minimum sea ice. We can also do this over glaciers, helping us to understand Greenland, for example, the land ice masses. So while the ISAT-2 mission has an active LIDAR, or a laser signal that bounces off the ice, and it can tell us how thick it is to an extent, we have other observations, such as looking at the differences in gravitational pull of two different satellites called GRACE and now GRACE Follow-On, that helps us understand gravitational or these major changes in ice mass, such as observed over Greenland. So what you can observe over time is the mass loss of Greenland's ice sheets, which we can understand because of these gravitational satellites. And we're continuing to move that forward with a GRACE continuity mission, which will be following up at the later part of this decade. Now, of course, understanding that sea ice loss, understanding the extent of Arctic movement of ice is critical for understanding the behavior of our oceans and of our vegetation. And so I call this the earth breathing, or many of us do, right? So we're looking at, through a combination of different observations, we can tell what the surface looks like, how the transition from arid to rainfall conditions in the Sahel, for example. We can see how vegetation changes over land, and then we can observe the health of our oceans, right? We can look at chlorophyll in our oceans and see where there is highly productive areas, such as coming off of many of the Earth's major river systems, and then, of course, where there's dead areas shown in purple. And so while we've had critical observations over time to really look at this important picture, we have new missions helping to really dive deeper into us understanding ocean content of chlorophyll and other key organisms that help us understand everything from aquatic viability and health, all the way through to where these aquatic organisms are going to be absorbing carbon dioxide, a key component of understanding the carbon cycle on Earth. So the mission that's launching soon is called PACE, which will help us understand this. It's launching in early January of next year, and will help us to understand and continue this record to provide the understanding of movement of organisms, both on land, of course, through vegetation and others, and in the ocean. And we can also understand the movement of our ocean through combining observations of sea surface temperature and currents. And so if you're looking at this in a big screen, you can see that this is called the ECHO model. So this is a model developed by the Jet Propulsion Lab. And in combination with the other centers, this is showing the coupling of how critical surface currents are to moving heat around our ocean and around our planet. And so by being able to understand and innovate not only our understanding of what the sea surface temperature looks like, a critical piece of understanding climate change, but also the sea surface height through new missions and altimetry missions such as the Sentinel-6 Mike Freilich satellite, as well as the SWOT mission, the Surface Water Ocean Topography, it helps us form this really complex web of information to connect the behavior and the health of our oceans. Now, of course, from the atmosphere, we can look at precipitation. So the Global Precipitation Measurement Mission, GPM, has some of the most advanced instruments to measure precipitation from space. And this helps us to connect observations from near real time. These are observations happening every 30 minutes around the world to major events. And so this is an example of a view from a recent storm that we experienced in the US called Hurricane Idalia. And so in addition to looking at this two-dimensional view, we can actually fly in and get a three-dimensional profile of these major storm systems, helping us to understand the patterns of convection and what makes these storms rapidly intensify. I was actually just listening to a former director of the National Hurricane Center who said only in the last couple years, we have been able to make a forecast for rapid intensification. And with climate change, we expect far more storms to rapidly intensify. So diagnosing the fundamental research of tropical cyclones and how they evolve and how they may intensify is a huge area of research to help us understand where they may go and who they may impact. Similarly, this is an example from another storm, but this is a view of Florida. And this is, if you look right afterwards, this is a view of what happened when a similar storm, Hurricane Ian, passed over Florida a little bit further south. And so what you can observe is these ocean colors changes, right? We saw the health of our oceans. And if you zoom in, with missions like PACE and understanding of what's happening in our coastal zones, we can start to better understand how the plumes of sediment coming out of river systems subsequent to the storms making landfall can affect coastal ecosystems, it can affect tourism, etc. And actually in Hurricane Idalia, which happened over the Labor Day holiday, which is a big holiday in the United States, there were coastal warnings for not going in the water all the way from Florida to North Carolina up the eastern coast. And so by being able to look at this integrated picture, have the observations and the innovation of instruments to measure this from space, it will provide us these important clues to help better understand the impacts on human productivity, tourism, and the economy. But in addition to the natural environment, with satellites such as the SUMI NPP mission, we can start to connect that to the human dimension. And so this is the same view of Florida that you saw, zoomed in a little bit. On the left, what you see is the night lights, right? So this is the ability of the satellite to actually observe the light coming off of these major cities. And on the right, you see the devastating loss of power as a result of Hurricane Ian passing over. Now, this type of information, in addition to being important to understand the extent of the damage, has been critical to connecting with emergency responders, the Coast Guard, and others to know what communities have been hardest hit and where they, for example, should install generators or more rapidly deploy supplies. And while I'm giving an example of the United States, this type of information is public and open around the world. Right now, we have a team and the NASA disasters team working very closely with representatives in Morocco, responding to the devastating earthquake. And our thoughts are with the country of Morocco as they really are moving to address the devastating impact of that event. So we work really closely to not only provide and enable information, but help people to get the right information that they can use to make effective decisions on the ground. And so the human signature on our landscape is critical, right? We're in the Anthropocene, right? We know that the signatures of humans on our earth have made an indelible change on the landscape. And this is an example from Las Vegas, the growing city of Las Vegas through 50 years of Landsat, right? A collaboration between NASA, the U.S. Geological Survey, and others. And this view helps us to understand how these cities have evolved. But what I wanted to point out additionally is that in addition to looking at how the city has expanded, you can see our water resources have been shrinking. And the question is, how is the confluence of understanding how much we have in freshwater availability from precipitation? What do we have in terms of our groundwater supplies from information from satellites such as GRACE? And how is our vegetation responding in our agricultural systems to these extremes that we continue to have on our landscape? And so the way that we can understand these complex webs of how these spheres interact is really through integration. And so a quote by Carl Jung is really, the wholeness is not achieved by cutting off portions of one's being, but by integrating on the contrary. So how can we bring these different pieces together? So I want to give you some examples. The first is understanding how we connect with data, right? We have a tremendous amount of data, not just from polar orbiting platforms, from near Earth orbit. We have it from geostationary orbit. That's what you see as the orange flashing. But you can also see we have data on board airplanes. We have data on the ground, and we work very closely with our international partners around the world to connect and make this data open. But all of the data points you're seeing right now are an example of 6 hours worth of data that gets assimilated, gets brought into one of our global models. And so the creativity and the importance of leveraging data assimilation, how we bring that into these integrated models, as well as artificial intelligence and machine learning, will really help us to better utilize these types of observations going forward in an integrated way. So if we think of an example more close to home, if you look at the response of precipitation, which is what you see in the yellow colors with soil moisture over Australia, we can start to understand and see the confluence of some of these spheres coming together, the extremes of the atmosphere with the surface. And so you can see some of these major storm systems come over, you start to see kind of brightening up, or the blue response from soil moisture. And so looking at this through a little bit of a different lens, this is an example of taking those extremes and using information from GRACE to look at major extremes in terms of extreme drought and extreme floods over time. And so this is work by my colleague, Matt Rodell. And what they found, and you can see this, is as we go forward in time, the events, the hydrometeorological events become more extreme. Okay, so let me play that just again, or it's going to go again. So what you can observe is this is based on a baseline that they set. We are seeing more extremes now. It's not something that the Intergovernmental Panel on Climate Change says we'll see in the future. We're observing that now. We can do that with satellites. And integrating our understanding of what that means, what those impacts are critical point of what we need to do as scientists, and some of our mantra for how we're moving forward in the NASA Earth Science Division. And it affects us in so many different ways. If you take agriculture, right, understanding not only the surface soil moisture from root zone, but also the groundwater, is critical for understanding when agricultural practices need to be changed, right? The U.S. Drought Monitor, which is operated by the U.S. Department of Agriculture and its partners, integrates many of these types of resources and NASA data into their models to better understand and forecast crop sensitivity to these stressors. Similarly, if you look at extremes, understanding the teleconnections, the differences between these extremes are critical, right? So on the left, what you see is the Nino 3.4 index, or the surface temperature anomalies. In the middle, you can start to see precipitation anomalies. And on the right, you see vegetation changes, NDVI anomalies, and a co-occurrence of risk of Rift Valley fever. And so what you can observe is that as we look at the strength of the El Nino, precipitation, and vegetation, we start to understand when we should expect Rift Valley fever outbreaks in Southern Africa. Now, I was just talking last week to a set of congressional delegates, and if you've heard in the news this summer was actually the hottest on record in the world, right? So we had the hottest temperatures we've ever had in the Northern Hemisphere this summer. And understanding the teleconnections, there was a huge heat dome in the Western United States. And that was because of Western Pacific's surface temperatures that was causing the stagnation of this heat dome over the US. And so understanding kind of how we can connect not just one type of disease, but look at all of these different types of disease outbreaks and the correlation with El Nino. Now, of course, El Nino is just a proxy for many other environmental variables, other atmospheric variables that help to indicate where we might have the onset of these diseases. But it does help us to understand that, as we know, we live in a very complex world, and the integration of information is critical to understanding how we can better prepare. So another area in which we have all really felt it very strongly is in fires. We know that fire weather is changing and extreme weather is changing to motivate and move fire activity. And so what you're seeing here is the evolution of, or the observation of extreme fire called from a wildfire intensity observed from what's called the SUMI NPP mission, right? So a thermal detection of information. And so we've been working very closely with Australia to look at the signatures of pre-fuels and active fires, as well as model smoke processes. And so understanding the confluence of the evolution of pre-fire activity and fire weather, active fire fronts, and post-fire impacts are that critical arc we need to really understand the true fire impacts. And I know that I'm preaching to the choir here, but this is something we're actively working on from the surface, from the air, and from space. And so one example of this is actually the Dixie Fire. So this is on the west coast of the United States. And so what you're seeing here is the evolution of the Dixie Fire. It was the first fire to go over the ridge line, which really changes the whole plan that we had on understanding fire behavior. And so you see the red dots are the active fire fronts, and you can start to see how the ridges are expanding in terms of the burned area and how rapidly this can change. And so by being able to really get a sense of the real-time evolution of active fire fronts, something we're working on very closely with our operational partners, using key satellites from a geostationary orbit, as well as from satellites like Terra and Aqua, it helps us to better understand fire dynamics and the initiation zones throughout the day. Now, of course, we have gaps in our coverage, and so we're working very closely and collaborating with Australia and with Canada to better understand how we can form an international constellation or virtual constellation to understand fires, the fire ecosystem, everything from science impacts all the way through to helping operational responders on the ground respond to these fires. And one of the critical parts of fires is, while they're deeply personal and they're locally devastating, additionally, the impacts of the smoke affect air quality, not just locally, but it can expand significantly around the world. Earlier this year, the Canadian wildfires were one of the worst on record, and we had extreme air quality issues in where I live in Greenbelt, Maryland, or in Maryland near Washington, D.C. And so the plume of very poor air quality affected our entire region for several days. And people really felt that personal relationship with fires that initiated so far away. So what you're seeing here is actually a model that helps us connect observations of different types of aerosols, different particulates in the air, and how these traverse the globe through things. You can see the transport of smoke from the Australian wildfires. You can see sulfates as well as dust storms coming off of Africa, forming the nuclei for hurricanes. And this just shows the importance of integration and connection of the spheres that we're talking about these next 2 days. And then finally, we need to understand the impacts more broadly. So this is a model showing carbon dioxide and the evolution of that. Now, we have more work to do, just as we do in fires, to understand global transport of CO2 and observations of where and how it is moving. And so the administration has made a critical push to better understand greenhouse gases. And so we are working very closely with our federal partners to better understand and trace different types of greenhouse gases, including methane and carbon dioxide. And a critical piece of that is new missions that have these observations from space, and that we can connect them with point sources on the ground to make sure we check and understand that we can effectively attribute the sources of greenhouse gas pollution. So finally, one of the areas most impactful for me is informing. And we know that knowledge is power. And so working as colleagues, as scientific colleagues, to really address what we know about our climate system, what we don't know, and what we should be doing about it, right? What are the solutions that we can help to suggest or to provide information for decision makers to have those actionable solutions? So first, we know that the Earth is changing. We know that human caused climate change is because of humans and the release of carbon dioxide and gases, greenhouse gases in the atmosphere. And so an important part of this is, people say, why? It's been hot in the past. Well, it has, but not like this, right? Not at this rapid pace. In fact, I just did a talk by the head of the Goddard Institute for Space Studies, who estimates that a quarter of the warming we've experienced is similar to the quarter of the cold temperatures we experienced during the Ice Age. And so we're making drastic changes to our planet right now. And we know that it can only be explained by a combination of natural and human drivers. Okay, so this is what you're seeing here is global changes in the mid-stratosphere on the top. You see the lower stratosphere, surface temperatures is the third, and then ocean heat content. And you can see Arctic ice anomaly as well. And so as we get to the 1980s, you can start to see that very clear divergence between natural drivers only, the observations, and a combination of natural and human drivers. And so this is so important because we are understanding how the planet is changing, and we can observe these changes. We've been making predictions since the 1980s, and unfortunately, they are pretty good. So we need to understand how these changes may impact the surface. So what you're seeing right now is actually the evolution of corn and wheat, combining our climate model, something that we provide, working really closely with our partners, with crop models. So you can see, apologies for the wording, but you can see that through maize and through wheat yields, I just want to make sure we had the most current, that the growing regions of our Earth are going to change, right? And so these indicate where we think that by the end of the century, we will have changes in fundamentally where our food comes from or what we can grow. Now, maize is not just for eating. We know that maize is in Tesla batteries, and maize is in wallpaper and glue. So it affects so many different economies, and providing this information to understand, for stakeholders to understand, is critical to advancing our science, right? And so just to close, the question is, what's next? So first, the NASA has invested in what's called the Earth System Observatory. And so we're looking at 5 different key measurables with this interconnected system, focusing on clouds, convection, and precipitation, how that interacts with aerosols, understanding and continuing the GRACE measurements with mass change, which is now called GRACE-C as of last week. And then looking at how our surface is deforming and how natural hazards may be impacting the surface. And then finally, how surface biology and geology may be evolving over time. So together, the goal is to create this integrated view of an ESO, an Earth System Observatory, to help us understand and propel our science into action in the next decade. Other things that we're looking at is looking at these connections and these gaps that we know we still have. And so there are missions such as, there's observations such as in the planetary boundary layer, right? That critical zone of where we breathe, where we still don't have space-based measurements of the boundary layer in our atmosphere. And so this is an area where we are working to better understand the types of technology advancement needed to understand this area, as well as what types of observations from the ground we will be able to have to corroborate this, the planetary boundary layer and how it changes throughout the day. Critical investments in new technology that are needed for the future. And so an additional part of how we're doing this is to really frame this in terms of an earth science to action strategy. And so by being able to look at first combining our foundational knowledge through missions with Earth system science research, applied research, and modeling, and then connect those two solutions and working together with stakeholders, different aspects of society to help advance their use of information in a public and open setting, and then communicate those results to different audiences working collaboratively with our stakeholders around the world. That is how we're striving to accelerate the impact of this work. So finally, I just want to highlight that there's a lot more to do. The work's not done yet, and it's an all hands on deck effort. And so how we inform regional to global solutions, everything from sea level rise to economic impacts and prosperity, how we inform food security and water management and natural hazards, all comes down to understanding those spheres that you talked about. And so I challenge you today to have the hard conversations about what we still don't know, where we could combine observations to get something more than the sum of its parts, how we can work collaboratively with all different disciplines, with different communities to really inform where changes are needed the most, and how we can work together as a community to be informed, to be involved, and to be inspired in what's next for our planet. Thank you so much, and I'm very happy to take questions if we have some time.
Okay, wow, Dalia, that was fantastic. What an amazing start to our 2 days of conversation here. It was very kind of you, Dalia, to open up to questions. I'm just scanning the room. I kept on thinking of questions, and then you would then nail it in your following slide about what I was going to ask. And one of them was actually going to be, what can we do? Is there anything... I'm putting you on the spot a little here, but is there anything that when you think of Australia and what we can do here, is there anything that really leaps out at you that you think, hey, I wish that group of Aussies were able to realise this or do something along these lines, Dalia? Is there anything that you can really bring home to us to inspire us for the next 2 days?
Sure, absolutely. You know, we know that extremes, right? So we're talking extreme flood, extreme drought, extreme temperature, water quality, air quality, right? Are going to be exacerbated going forward. And so I think the first thing I would say is research in those areas, how we understand those and experience them locally, what we can do to better forecast or predict what extremes may be and what might be causing some of the local impacts of those is critical, right? So really looking at the extremes and how they manifest at a local level. I think the second thing that you can do, and we all can do a better job of, is engaging more people in the process. So I'm so thrilled to hear the early career speaker who's speaking next, and really hope that you can connect with the Aboriginal groups. We work with many of our tribal nations here to understand, again, what the Earth system, what Earth science means to them. They have many different lenses, and we need to really respect that and work together. Engage in students in the scientific discovery process, right? I think really challenging them to ask why and take ownership. You know, we all have the agency to help change, and the generation coming up right now has the power and the time to do that. And so really motivating them to get into the field of science and technology and engineering is critical. And then finally, I think it's to be open-minded, because we live, the planet is for all of us. And so international collaboration is critical. As I mentioned, we're already working very closely with many of our Australian colleagues in fires and in other areas. We've had field campaigns down in Australia. And so I think continuing collaboration internationally is critical for us all to help solve this together.
Oh, wow. Thank you, Dalia. Passionate, insightful, and inspiring. So thank you. You've actually inspired Beryl from our audience, who has a question for you. Hopefully the microphone will pick Beryl up, but if not, I'll relay it. So.
Hello, Dalia. Can you hear me? No.
Not so much, but...
Okay. It's Beryl Morris from Australia's Ecosystem Research Infrastructure Turn. You've talked about interconnections, and I'm just wondering whether you're aware of any international communities of practice that Australia should be joining to discuss integrated Earth so that we can move quickly and not just regionally.
How did you go there, Dalia? Yeah.
So, I didn't quite catch it. Would you mind? Yeah.
No worries.
Thank you.
So Beryl wanted to know if there were any international groups or communities of practice that you're aware of that we should make sure that we're part of in Australia.
Absolutely. So one of the fantastic organizations, it's one of the largest programs at NASA and in the world, is GLOBE. So there are many GLOBE schools already in Australia. And what this does is connect, I'm guessing many of you in the room have maybe heard about it, but connecting students with making observations at schools and contributing to a global network of different, basically taking measurements of different climate variables. So the GLOBE program has an international presence, and it's been highly successful at connecting. Other communities of practice, for those that are more on the space side, the CIAS, the Committee on Earth Observing Satellites, has a disasters working group. It has a land surface working group, and it allows groups around the world to come together to discuss the effective or the strategic use of satellite remote sensing on different areas. And so there's actually a new fires group that just started in partnership with Canada and the US and others that are really leading that kind of discussion of what I was talking about before, this virtual constellation for fires. And so those are two off the top of my head. I also know that, there are international efforts from the UN Assembly. UMETSAT is meeting right now that really help guide some of the frameworks for how and what we need to measure in the climate system. And so in continuing to engage in those international spheres is really critical in moving it forward and making sure that Australia's perspective is represented in the global stage, as I know you already are.
Fantastic. Thanks so much for that, Dalia. I have the task of making sure we keep to time, and you're right on it. So that's great. Thank you so much, particularly also because of the time zone differences between our two places, and I hope you get a great night's sleep. So thank you very much.
It's absolutely my pleasure. Have a wonderful meeting. I hope it's highly successful.
Terrific. Thank you. Let's all join and thank Dalia. Over to you, Jaden, to weave your magic there. But while you're doing that, I would, wasn't that great? That was a great start to, I think, the 2 days. Some of the images that Dalia put up there, I was like, oh, that is so inspiring to see that. So terrific stuff. We now, Dalia mentioned the importance of Aboriginal or Indigenous perspectives in here and in this discussion. And as I said earlier, this is as much about the people as it is about the science. And I think, hearing these perspectives from all of our community is going to be really important over how we take these things forward. So it's fantastic to start things off with a presentation from Jim Walker from the University of Queensland. And Jim's going to be talking to us about Indigenous perspectives on integrated Earth. Good on you, Jim. Thank you.
So, how do we move this on to the slides? Thank you for inviting me to speak here. Dalia, I think that you're supposed to have an early career researcher. As you can see, don't exactly fit that mould. So please bear with me. After listening to Dalia, I was actually thinking about changing this presentation and from Indigenous knowledge perspectives on integrated Earth to Indigenous knowledge integrated management solutions and resilience, because what we'll see, what I'm hoping to show you, is that throughout this presentation that there is value in engaging with Indigenous peoples, not only here in Australia, but also globally. To start off, I wanted to acknowledge the Ngunnawal and Ngambri peoples of the Canberra region, and I wish to acknowledge and pay respect to their continuing culture and the contribution they make to the life of this city and this region. I'd also extend that recognition to traditional custodians of all other lands on which our participants are gathered today, and particularly our allies, because quite often we don't hear an acknowledgement of our allies. And it's important to do that, because without them, our way forward would be severely curtailed. And I also acknowledge the ongoing role of Aboriginal and Torres Strait Islander peoples to society at local, national and international levels. This slide here, I guess, is to put me in context. For you, I'm an Aboriginal man and elder of the Yiman and Goring First Nations peoples here in Australia. For those who don't know, Yiman and Goring peoples are part of southeast Queensland, up around Bundaberg, Gladstone, Taroom, west to Taroom. Also a lecturer at the University of Queensland, member of the Science Advisory Committee of TURN, chair of the Science Advisory Committee for Earthwatch Australia, chair of First Nations Advisory Team for the Cooperative Research Centre on Transformation and Mining Economies, and chair of Murray Moora Aboriginal Corporation. The idea of that sort of context is to show that when we start talking about Indigenous perspectives of Indigenous knowledge, we're now getting a recognition in organisations such as these of our knowledge and what we can contribute to the solutions and management and resilience of integrated Earth. Why do we need an integrated Earth perspective? I think this is pretty well covered in the opening remarks and also by Dalia. And we saw that incredible technology that goes on through NASA. When we start talking about taking an integrated Earth system approach, it's complex. There's a gap between the magnitude of the challenges and governance and knowledge solutions presented so far. So also there is a need, therefore, to recognise and connect knowledge systems and to look for new perspectives. And again, this is, I guess, echoes exactly what Dalia said. If I would have seen her presentation before, I would have certainly changed this around, because I'm pretty much reiterating what she says in a different format. But then again, I guess reiteration is one way of reinforcing commentary and also thoughts and beliefs around how we see an integrated Earth system. I'm starting off with these international frameworks for two reasons. Is that from an Indigenous perspective, we have different rights. When you engage with us, you're not merely engaging us as stakeholders, but we are rights holders. In other words, it's pretty much mandatory for us to be included within consultations, decision makings about us. These are a number of articles, and this is part of some of the work that I do within Earthwatch, Time, CRC Time, TURN, and also within UQ. These articles give you an idea of why we have this interest within an integrated Earth systems. When you look through those articles, It's the right to remain on country. This is not a poor bugger me sort of approach, which is rather a technical term, I suppose, but it's one from a rights-based approach, therefore a strength-based approach. Us to have access to that land and waters and country means that then we actually then are able to have that commitment and to Earth and Earth systems, and within those, each of those 5 areas, cryosphere, biosphere, hydrosphere, etc., you'll see that us maintaining connection to country is vital for us to be able to report on it, manage it, and also offer solutions and to management of that, but also to resilience. Convention on Biological Diversity, Article HA, subject to its national legislation, respect, preserve and maintain knowledge, innovations and practices of Indigenous and local communities. Indigenous is used with a small I there, which is part of the way the UN writes their documents, which is rather unfortunate. Embodying traditional lifestyles relevant for the conservation and sustainable use of biological diversity and promote their wide application with the approval and involvement of the holders of such knowledge, innovations, and encourage the equitable sharing of the benefits arising from the utilisation of such knowledge, innovations and practices. Read through those rights. I'm not going to dwell on them, but what you don't see in there is a closure of country. What you see in there is to say that we've got these rights, however, we're open for business. We're open to contribute to these solutions. We're open to impart our knowledge, but we have the rights to have for protection around that knowledge. In the context, can I just grab some of this? Is that water? Is there water there? Oh. So in the Australian context, everyone's probably seen these maps before. And what we see up there, of course, is a map of Australia with Indigenous land boundaries, or First Nations land boundaries. And as you can see from that map, there's no part of Australia that are left uncovered. Put that into perspective, I guess, I'll put that into context. When you look at the biomes, Australia's biomes, then, of course, you're looking at Indigenous knowledge right across Australia of all those biomes. When you look at native title and Indigenous populations, where they're scattered throughout Australia and where they're placed throughout Australia, you'll find that there's a necessity to involve people who live on country, not only through our rights, but it makes good common sense, especially when you're talking about resource applications and also for discovery or maintenance and management of these biomes, but also of country. And when I talk about country, we talk about sea country as well as land and fresh water. When you start to think about it, and I'm going to press this to just see whether it works. Ah, yes. So when you start to think about it, as you start to think about it, if you're trying to monitor out here, it's very hard to do it from a little place down here. Is that there? Yeah, Canberra there. So making decisions about country and monitoring, while we may have that space technology, how you do it on the ground and actually seeing how it, what it actually is happening on the ground, it makes sense to engage. To engage from here, you can have all the monitoring stations you like out here, but who's going to record it? You're going to fly scientists in and out, researchers in and out. Why not use the populations that are out there? There was a belief when I worked with CSIRO that this technology is too complicated for Aboriginal people to understand. Part of my job with CSIRO, which was prior to coming to UQ, was to manage their National Indigenous Engagement Office. what we found there was part of our recruitment was in their cadets and internships, is that we actually had Indigenous people coming in, learning science. They were from marine scientists, and we even actually had a couple of astrophysicists come in. These are young Indigenous people who then who have that knowledge, and when we start looking at the difference between Western science and Indigenous knowledges in science, I think that you'll find that, I'm hoping you'll find that there's in this, it's worthwhile, the integration. The integration, two knowledge systems coming together at certain points, but not fully integrated, otherwise some knowledge is lost, especially from the Indigenous perspectives. Our Indigenous knowledge systems, like Western knowledge, are complex and sophisticated. Indigenous knowledge systems are increasingly recognised as presenting viable alternatives in addressing contemporary issues, not only around climate change, not only around resilience, but also and in that resilience, rather, it's also about food security. There's now Aboriginal people doing research into alternatives to wheat. They're looking at natural grasses as an alternative to Western crops. We're looking at our own root crops to see if they offer an alternate to potatoes. And so there's now a lot of investigations in our traditional knowledge insofar as its applicability in the 21st century. So when we start looking at Indigenous knowledge systems, inherently contextual, it's collective, holistic, land and water and sea country informed. It's experiential. If science is about observation and experiments, then of course we've got 60,000 years or 2,000, more than 2,000 generations of observation and experimentation. It's relational. What we see, and also when you look at relational and holistic, we actually don't see all that the 5 spheres that we've talked about before. We see it all as an integrated whole in any way. When Beryl asked me to come and talk about this in relation to biosphere, I started to think about it, and I thought, well, you know, we're actually talking a lot more than just biosphere here. We're talking about all those different spheres, and I'm hoping to show you, demonstrate that a little bit later on. It's cumulative, it is place-based. Some criticisms of Indigenous knowledge systems is that how can it be considered as science? Because it doesn't transfer. I think what you'll find is that it does transfer, because when you add technology to it and some of the Western science knowledge to it, it transfers very well. And I think that there's a number of, there's certainly a number of instances that we can, that I can think of, especially say, for example, around spin effects, where it's now been within UQ, and also with the people up around Mitakootie and Cloncurry. There's been some great innovation and invention within the use of spin effects for a variety of reasons. And this is a very old diagram. You've probably all seen this before. When we start talking about this connection to country, land and country, you can see from up here, from this map, it's an old one by the Institute for Aboriginal Development out at Alice Springs. And what it basically says is that the lives of Indigenous peoples relied on our knowledge passed on from their dreaming, and this became our ways of knowing. Knowledge of how the earth was formed was essential for survival and livelihoods. And I'll go through some of that later. Up here, of course, land, and that land includes land and waters. And from here, we got everything came from that. So when the Europeans came to move us from country, broke down our languages, broke down our cultures, then some of that knowledge was lost. It has been, it is starting to be revitalised, and that has happened over the last few decades. Of course, here, the ceremonies, along with the ceremonies, and I'll talk a bit about songlines and these songlines, etc., a little bit later on. But in here, and our connection to country, of course, comes down to our body, our dreaming. So my dreaming on my father's side is cabbage tree, palm dreaming, and emu. And my totem is emu, so that connection, flora and fauna. On my mother's side, my dreaming is Warringari, and the Warringari is the Dawson River, so it's in water. And my totem there is freshwater long-necked turtle from the Warringari. My body paint is bunya pine, and so what you see is a continuing connection to country through totems and totems, body paint, and dreamings. This goes on to, it digs a lot deeper than that, because with those connections then comes special responsibility to country. We see within this, of course, this human world, physical and sacred world. But at the centre of it, of course, is country, because where you come from is where gives you an idea of place. This idea of it being localised, that knowledge being localised, is true. But as we travelled across country, we actually came across, through the use of songlines, we then also became knowledgeable of other land and waters of other people's countries. In comparison, with the Western, with our epistemologies and ontologies, and with that last slide I showed you, Western science is mostly analytical and human-centric. It produces constructs of how the planet works. It perpetuates a view that humans are independent of the systems they study, and that is the separation of subject and object, and between humans and nature, whereas we see it all well and truly connected. So when we look at these constructs, in the first we see those Earth system domains that we spoke about, which is the subject of this symposium. We see the environmental challenges that come through it, and then we see the societal needs of food security, intact environment, access to water, sustainable provisions of resources. As I said before, but they could be interconnected through technology, human and cultural capital, but within that human and cultural capital is also social capital. Technology, I think, interlinks all these systems, whereas for us as Indigenous people, those things are already interconnected, and we see no separation of them, because as I talk about totems and dreamings and body paint, there's also the stories that come about. And it's those stories and myths and legends that people dismiss quite easily and offhandedly are ones that also contain the knowledge. The alternative would be, holistically, the alternative would be promote dialogue across and between Indigenous knowledges and the social, natural and physical sciences, while also recognising the socially constructed character of knowledge. Knowledge systems are sense-making, trying to create order out of seeming disorder. Indigenous ways of being and a way of knowing are intricately connected with country. Country encompasses all natural elements, as I showed you on the Jukapa, whether they are on ground, in the water, or in the air. Human-centric approaches are most often absent in Indigenous languages. They reflect the profound and deep respect given for all human and non-human entities. And just to go back what you see here is this Jukapa Walta, which is this dreaming, which is what what is commonly known as the dreaming. But as you can see from there, it is all interconnected with these lines. And so what we don't see is a separation, but an interconnectedness. Some examples of interconnectedness with nature. We've had, generally around the world, we've had nature-oriented calendars, both solar or lunar, which integrate ecological awareness through synchronicity, I can't say that now because my mouth's gone dry, with the planet's natural cycles, whereas Western-based perceptions of time disconnect with the sources of life, including water, air, earth, and sunlight. And many of you have seen these calendars before. Yes? Yep, I can see some nods. And of course, just to blow it up a bit, this is one of those calendars. This is from the Daly River, Niue country, for Niue people. And of course, what you see within this is this interconnectedness. The whole idea is, and I'll know if I'm going to resentment time because it's morning tea after me, so I'll make sure I don't hit that mark. So what you see here with this interconnectedness is if certain things don't happen, if things happen, different things will happen when other things happen. If there's a breakdown in that by virtue of climate change, development, particularly say in urban areas, then other markers just don't appear. And so what Dalia was saying when she was looking at that, the change in the Arctic Circle and the changes of the Earth's atmosphere, Indigenous people see that firsthand, and they see it first. Because generally they, not only here in Australia, do they live in those remote areas and on sea country where they see those changes. Freshwater mussels, a rise in temperature, a half-degree rise in temperature of the water means that freshwater mussels open too soon and therefore they're not ready. Warming means that certain grasses won't grow within river systems and therefore the swans won't be able to gather that grass in order to lay eggs. And we see that going down the Murray. Having seen that interconnectedness in here, it not only relies, it also is reflected within groundwater systems. What we see here in this, when I was talking about song lines before, in the Perth basins, the song lines follow the sedimentary geological features. The purpose of showing you this is that these are the song lines. What they do tell you is that as you go across country, you can expect to see certain things, and that enables you to traverse the country. These song lines covered all of Australia as we moved about, traded. We weren't nomadic, we did have our own country. Yemen is different to Goreng country because our neighbours, Waka Waka and Woolly Woolly, they know their country as well, but we do come together with others in the Bunya Mountains for ceremony at certain times a year. These song lines then allowed you to travel country, or travel the country of others, with their permission, of course. But the song lines said that in dance and in song, more or less said what you can expect to see at certain times of the year. So in other words, when things happen, you can expect this, that interconnectedness from those calendars. With climate change, that changes the song lines because watercourses will dry up, some plants won't grow. As it moves from west to east, we'll see those song lines slowly start to change because some plants won't grow in certain areas. Emus won't go in certain, emus can't graze, other game can't graze like kangaroos, etc., because they'll start to move. Whereas the song lines from before would say, this is what you should be able to see. Now you may not be able to see it. So therefore, we're able to give you those indicators. And we all talk about, for as Indigenous people, we now talk about how those song lines have to change because of this climate change. Here we see the spear thrower Woomera, and what you see in there are the song lines engraved within that Woomera, and for the owner to traverse certain country. The idea of the groundwater and how we know of groundwater is in relation to, it's a story of, we call them Mundagadi, but other people call them her rainbow serpent. She was fighting with a brother. The brother, because the brother ate her children, as she fought with him, he went into death throes, where he tried to get away from her. He landed where he hit the ground near the coastal regions. The water flowed in, that became the rivers. In the inland area, when he dived into the ground to escape his sister, then that became, the water flowed into those as well, and that became all the groundwater. So that groundwater is depicted within these song lines, and particularly around that Perth Basin as an example. The State of Environment report now is, we're getting recognised by government. Indigenous knowledge systems have been recognised by government. And as we all know, with all due respect to government officials in this room, is that we know that government's generally the slowest one to move on these, and especially around recognition. But that's started to happen. We've seen Indigenous co-authors with the State of Environment reporting, looking at this in interconnected perspectives. And what we also see is then we see Indigenous people, we see scientists who are Indigenous people. So they're not Indigenous scientists, they don't do an Indigenous degree, they do a science degree, but they happen to be Indigenous people who bring an Indigenous perspective to help with this integration of knowledges. I'm going to move on through this, I've spoke about that. And what we see, a recognition there, is country is just not the physical land. The report within that State of Environment report details countries including land, sea and sky country, and it includes things on it such as the plants, the animals, the people, the rock formations, everything on it, and embodies that relationship with it. Again, there's that integrated approach already. The case study that was there was in the case of the Jungan people who have stories about country that is now covered by seawater, and they still talk of country, and they have that, they are able to bring that knowledge. I work with a number of scientists just down the corridor from me, and they tell me about before this. There are stories of people Indigenous people in coastal regions who are able to tell them stories about what lies below the water. When we see native title on sea country, there are stories about that sea country that still exists, and that scientists are now starting to utilise that knowledge to better understand what's below the surface. I'm going to go on to this last slide. I'll skip that because part of what we need to do when we start talking about motives to harmonise, the basis of that, and some characteristics. I think that we've pretty well covered that. Before, and so how we better understand this, of course, is to insert so that our scientists of the future are better aware of Indigenous knowledge systems, is to actually indigenise the curriculum. Again, which is part of my job at the moment, which is in developing a second year course elective within the Bachelor of Science at UQ. It's also been promoted by this National Strategies for the Universities Australia, which is a collection of all the universities within the country. And what we see in here is that a process that models how Indigenous and non-Indigenous people can work closely and respectfully with one another together. But I guess from this, looking around this room, there's quite a few people here who are involved and know about that already. But it's for those new and upcoming scientists. I think the way we change how we integrate knowledge systems is to do it at that tertiary level. And this is, I want to finish on these next two slides. And the whole idea for this integrated Earth system, for this integrated Earth symposium and onwards, is a notion called Dadiri. And Dadiri is deep listening. It's more than just words. It's about listening to country. And it's one in which, as we walk country, you listen to country, you observe a lot more, you look up as well as look down. But Dadiri, in deep listening, is also about how we come together with our Indigenous knowledge systems, Western science systems, and listen to each other. So it's a two-way learning process, and part of Dadiri is also a two-way learning process. One way of doing that is to start looking at how you might construct models to allow for convergence of Western organisational constructs and Indigenous societal frameworks, but also to enable better interconnectedness and transference of Indigenous knowledge systems and vice versa from Western knowledge. So what we see here within this is this Indigenous elders. If you've got different projects, make sure you've got that representation. There's an integrated approach already at the local level, but of course, as far as the whole project as an integrated approach, it's built on the ground up with feet, etc. But if anyone wants to talk a bit more about that, I think that it might be better to catch up with you outside of this. Thank you for the privilege of your time, and I hope that you've found something of interest. Thank you.
Thank you very much, Jim. You almost made me enforce moderation upon you, but you hit the time right on the buzzer. So well done there. I am also conscious that we are coming into morning tea, and I know many of you in the audience will be keen to also have a jug of Hydrosphere to replenish yourself. But before we do go to morning tea, Rebecca, we have an announcement from you just to bring to everyone's attention, and I think I need to just forward. Rebecca, if you could speak to this, and then we'll let everyone loose, but thanks, Jim.
Yeah, thank you, Jim. That was wonderful. So tomorrow we're focusing on data, and in the lead up to that, myself and the digital leads, we've put together a Google spreadsheet that we'd like you all to just try to contribute to. So there's some instructions in there, there's some tabs for the different spheres or NCRIS capabilities. And we're just asking, I suppose the five of us are going to be talking tomorrow about our knowledge, but obviously we need to get that from everyone as well. So please feel free to fill in those tables. If for whatever reason you don't want to include those tables or don't want to think that way, please feel free just to be freestyle and create your own tabs and add whatever information you have for us. We're hoping that this will feed into the white paper as an appendix. Thank you.
Terrific. Thank you. What a great start to the day with Dalia and Jim. Fantastic foundation for what we've now got for the rest of today and tomorrow. But what we also need as our foundation is to go and have a break, chance for some morning tea, chance to also just catch up and have a chat with each other. And what I'd like to do is keep to time, and that means that you've got, I think, 24 minutes, and we will be starting again at 10:55 with the geosphere. Okay, so thanks everybody. Let's stay